Hey guys, welcome to this topics video here where I took this SBAC question. A couple things stood out on me when I looked at this. One, I thought it'd be a good example to kind of do a little bit of spreadsheet capabilities within GeoGebra, what we can do with it. And again, depending wherever you wanted your lesson to go, just give you that spreadsheet functionality. But also a thought too, or just share a thought of mine. When we look at these number lines in one variable, these are great, but I like to have my students understand that when we graph, the whole point of these kind of number lines is that if we have an actual coordinate system, right, like a y-axis and an x-axis, then that is exactly what this number line is. So the question becomes domain values, right? And help students understand that when we do a one variable number line, and maybe not all the time, but for majority of it, we talk domain and where our input, especially with inequalities, right? When x is greater than or equal to something, we usually do something like this, right? But really, if we combine it on a coordinate plane, we're talking about what input values give us something, or, vice versa. So kind of a chat with that, and kind of share these kind of thoughts, because when we're trying to find what interval for x, we're saying in the x-axis, what interval is our actual solution to this, right? So you have some inputs going from 0 to 8 of a function. So depending on what the function is, here's the outputs we get. And then some second function g of x, we have some other function or some other output values. So the question is, in what input between what two numbers, since it won't be in the whole number, but obviously because we don't see where the outputs are going to be the same, then what interval is our solution laying within, right? On the x-axis, between what two x values is the actual solution where these two functions are the same, right? So one approach is just using the table, noticing the f of x values are less than g of x until we get to this value, right? Now all of a sudden the f of x value is bigger than the g of x, so I would imagine in between 5 and 6, somewhere in here, our solution is going to lay. So on the SBAC test, they would actually highlight that little interval and call it good. All right, so let's actually play around with GeoGebra. Let's enter these values into a spreadsheet. So when you do that in GeoGebra, let me open a blank screen here. So we have our GeoGebra window open. If we go to Options, View, and we go to Spreadsheet, we'll have a little spreadsheet pop up. If we wanted to make this look just like the picture, where we title the columns x, f of x, and then g of x, then if we want to use letters, it's always a good habit, especially when we're talking f of x and g of x, to use the double quotes. And double quotes then allow us to title without changing anything. Because if I didn't do that and I just said x, it's going to give me the y equals x line, and I don't want that. I just want to title this column x. So I'm going to use my double quotes, and GeoGebra knows that that's a string, or it's a word, right? So double quote, this column is going to be our f of x values, and then if we double quote this will be our g of x. And then that way GeoGebra won't do anything funky with our titles. It just knows that it's words, okay? So now we're going to go ahead and fill out this spreadsheet as we see it here, which I already did in advance. Oops, not that. Here, so here is my spreadsheet that I just filled out based off of the table. So let's take a look at what each function looks like. Okay, so we need our coordinate, we need our axes and our coordinate grid up. Okay, so here's how we can make some points. Since we have input and outputs, right, there's 1 point, and we actually have 9 points here. Then if we highlight just the inputs and the outputs for f of x, notice our tools change up here. Now we have spreadsheet tools or some statistics tools, right? So this third toolbox where it says create list, we don't want to create a list, but we want to hit that little red arrow and create a list of points. So if I click on that tool, a little window pops up. Let's make sure that in our preview window that if we put in a 0, we get out -5, put in a 1, get out -4. So that's the relationship that we want. So let's hit create. And then we can kind of take a look and see what our pattern kind of looks like. Right, so if we look at this, it's looking relatively parabolic, right? It's not linear for sure. So what we can do if you want to get an equation, for example, maybe we want all these points. Let's just, for right now, let's make our f of x points a certain color, like maybe red. Let's make them all red and make them a little bit bigger. Oops, and I made an arrow, which is fine. There's our f of x points. So now let's graph our g of x points. So what I'm going to do is I'm going to drag my inputs 0 to 8, but because I want to skip this b column, this f of x column, and grab these outputs, I'm going to hold control down on my keyboard, and I'm just going to click and drag my g of x column. So now I have my same inputs with our different g of x outputs, and now I can go back, grab my create list of points tool, make sure that my relationship is what I want it to be, put in a 0, get out 120, put in a 1, get out 103. Okay, hit create. And now we can kind of see where the two patterns are going to cross, and this is really the solution to the actual aspect question, what interval. And if I want to change my scales, instead of jumping by 2 here, I'm going to hold control on my keyboard. I'm going to hover over my x-axis, and then I can drag my scale around. Which, oops, I just want this to jump by 1s. So there's my jump by 1s, and we can see they're going to cross somewhere in between 5 and 6, and there's our solution. Just to show you some more capabilities of GeoGebra, if I highlight my f of x input-output information, not only can I do points, but I can actually have GeoGebra do a regression for me. So this second toolbox here, I'm going to do a 2-variable regression analysis. All right, it looks parabolic, and again, it's just going to show us our data. Okay, we're going to take this column as our input, this is our column for outputs, right? And then let's analyze that data. So here is our actual data now in a nice fit window. And if you look at the regression model down here, it says none, but because it looks parabolic or quadratic, let's go ahead and pick that, which in GeoGebra is a polynomial. And then our degree is this little button down here, a little checkbox or whatever. So here is our expression, right? X squared minus 5. We can evaluate points if we wanted to. We can also, well, there's two choices. I wanted to graph this. I think I'm missing something. Well, I know my expression is x squared minus 5. So over here, I'm just going to type x raised to the second minus 5, hit enter, and I'm going to see that curve fit. So here is our f of x function, x squared minus 5. And then let's go ahead and figure out what kind of pattern is this. And if we look at this data, which if I highlight my inputs, hold control, highlight my outputs again, and I go over here to 2-variable regression analysis, it has our points backwards. So how do I fix that? Maybe if I highlight my g of x and then my x. It seems weird, but it worked. Now I have my inputs and my outputs. Always a good idea to see what's going on here. Okay, so now it's not, it kind of looks like here we have some kind of absolute pattern going here, right? So, I don't think we have an absolute graph, but maybe if we went linear, what if we just got rid of those? Sorry, I'm trying to figure out how to figure which graph is this going to be. An absolute value is piecewise, really. There's no absolute, so to speak. I'm just trying to figure out what we got here. So I'm going to take these points here, figure out what this line is, and that might help me figure out my absolute value too, right? So if I just do the line, and analyze. There's a nice line for that. Negative 17x plus 120, right? So maybe in my absolute value, notice where the vertex looks like it's at. If you think about this, it's at 7. So what if we put in that 17 times the absolute value of x minus 7? Let's see what we get. Hey, look at that. There's our function, right? So we now have an absolute value and a quadratic, and the whole point of that little mess right there is so that we can see the actual functions and show you the regression capabilities of GeoGebra. And now, depending if what level you're at, you might ask yourselves how to algebraically solve for that point. Where exactly does it cross? And again, if you want to get a good estimate, potential exact, if you get your point tool and click on the actual intersection. My tablet's nice and slow. It creates the intersection point, which tells us that it's 5.51, and we would get out some output of 52.35 or somewhere around that. So anyways, guys, I hope that made sense. Showed you some spreadsheet capabilities, how to graph points based off of input-output values, and then also some regression capabilities. And you can see the equations allows that math conversation to get deeper and deeper depending on how far you want to go. Good luck with that, guys, and I hope that made sense.